All right, this example, we are going to prove the triangle angle sum theorem, but let's get some vocab into our notes first so we can do the proof. First, we have the parallel point theorem. That says, through a point not on the line, there is one and only one line parallel to the given line. So what that's saying is, if you have, let's say, line A, and then you have a point not on the line. So here's point P. There is only one line that goes through P and is also parallel to A. Let's call that line B. So if this is happening, then line B is the only line parallel to A that goes through point P. All right, next we have the triangle angle sum theorem. The sum of the measures of all the angles in a triangle is 180 degrees. So a visual of that would be if you have triangle ABC. So basically, if you have a triangle, then the measure of angle A plus the measure of angle B plus the measure of angle C will equal 180 degrees. All right, so now we're being asked to actually prove that that's true. The three measures inside a triangle will add up to 180 degrees. It says make an informal paragraph proof. So we'll write this out in steps, and then that will make it informal. So step one, we are going to draw a line through point C that is parallel to segment AB. So what that looks like is drawing a line through point C, and I'm going to say that it's parallel to segment AB. So there's my parallel arrows. All right, so step two, if we go back up to the picture, we just created an angle 4 and an angle 5 all there at C. What we have is a straight line, and we have angle 4, angle 3, angle 5. We know that those angles will add to 180 degrees. Postulate. So we can say that the measure of angle 4 plus the measure of angle 3 plus the measure of angle 5 is equal to 180 by the angle addition postulate. The small angles will add up to the big angle of 180. All right, so step 3. We're going to use the fact that we have parallel lines, and we're going to identify some alternate interior angles. So this line is parallel to this line, and here is a transversal. So you've got parallel lines cut by a transversal. That makes angle 4 congruent to angle 1 because they are alternate interior angles. So by alternate interior angle postulate or theorem, We know that angle 4 is congruent to angle 1. And then we also have parallel lines cut by a transversal over here. And angle 5 will be congruent to angle 2 because those are also alternate interior angles. So I'm just going to add on angle 5 will be congruent to angle 1. No, not angle 1. Angle 2. So we created that line. What that gave us are some congruent angle measures. Now what we're going to do is we're going to use substitution and substitute these into our three angles that we know add up to 180 degrees. So our conclusion we know that angle 4 is congruent to angle 1. So we're going to substitute in angle 1 for angle 4 plus angle 3 didn't change plus, but we know angle 5 is congruent to angle 2, so we're going to substitute in an angle 2, and that's going to be equal to 180. We're allowed to do that by substitution. And what we just showed was angle 1 plus angle 2 plus angle 3. Let's throw, those should have the measures of those angles because we are setting them equal to 180 degrees, which is what we were trying to prove.